Hello everyone. Hello everyone. So let's wait for 5 minutes. हाँ बैठूंगी. So hi. Actually, during last week we discussed around week 12, and then we also saw some of the problems related to week 12. But when I asked like what is a doubt, how can I take the externalization, so many support on week 11, especially the graph. How can we solve the graph and graph related problems? So I'm revisiting the week 11 lecture material, and I have also some of the problems related to week 11, so I will be solving that. Okay. And I hope whatever it is not clear, please, those who are not able to join, they can text me, mail me before exam. So, okay. A graph or a network is actually a structure used to represent the relationship among the objects. So, as we can see, some of the social networks or web graph or web search. Okay. So, a graph will have the vertices and the edges. So, vertices means the nodes that we are talking about, and the edges means which is the connectivity, I and J. So, undirected graph means there will be not any arrow in that, but the directed graph will have the arrow associated with it. So, for every arrow, you will have the weights. So, in order to have the weights, for example, a walk is not a directed one. But if we see a path, where path can be a directed one. Okay. So, these are some of the examples that we also saw. Okay. So, but yeah, there will be no repetition of the vertices. So you need to make sure. Okay. Whereas cycle is a path where the start is equals to end. So if we see the connected graph, so a connected graph is actually an undirected graph, which is also called as connected graph if there exists a path between each pair of vertices. So a undirected graph which is not connected can be divided into number of connected components. So not time in case of directed graphs. Okay. A directed graph is actually strongly connected if the directed paths exist between each pair or vertices. So what is that? Means strongly connected means connected in every sense. Okay. So suppose how to calculate the distance now. So the number of edges present in the shortest path from I to J is called distance between the vertices. So in distance, if either you calculate from I to J or J to I, that will be same. Okay, so diameter is actually the largest number between two vertices. Okay, so since the externalization is only for 1 hour, so I'll go a little faster. Yeah, so graph adjacency matrix. So graph adjacency matrix will have the properties with n vertices and m edges. So a square matrix A, suppose it is having the size of n cross n. The adjacency matrix when Aij, the ith entry, is actually the weight of the edge from I to j. Okay, so but yeah, you need to make sure that you need to normalize with respect to row, not respect to column. Okay, and then only the adjacency matrix will work. Okay. So if you want to write for this particular graph, so how will you write? You will have 1, 2, 3, 4, 5 nodes in one side. You will have 1, 2, 3, 4, 5 nodes in other side. And what is the weight associated with 1 to 1? It is 0. With 1 to 2, it is 1. Like that. Okay. For unrelated graph, we can construct a symmetric graph adjacency matrix. Okay. In case of unweighted graphs, the entries in the graph adjacency matrix are either 0 or 1. Because in case of unweighted, either you can say whether it is connected or not connected. Okay. So power of adjacency matrix, if we want to calculate that, okay, how would we calculate? So suppose A is a binary adjacency matrix with entries 0 or 1. So A power k, where the ijth entry and A power k is actually is equal to the number of walks from I to j of length k exactly. So means if the length is it is asked, so how will you calculate? It is equal to the number of walks from vertex I to j of length k exactly. Okay. So by induction, it will be for like you want to prove it. So I'm leaving the proof now. Uh, yeah, but there was a question that also asked many times in my class. I don't know why students didn't join my class today, but I reminded many times. Like there was a question related to strong connectivity of the directed graphs. So let A be any n cross n directivity adjacency matrix. So if we call A as associated graph G strongly connected, if and only if it has every uh, entries as a non-zero. The summation of the A power k has every entry as non-zero. So also we need to normalize with respect to rho. You remember this. So if we normalize the adjacency matrix and eigenvalue eigenvectors, so if A is adjacency matrix and P is a normalized vector matrix, so a directed graph. So remember, what is the difference between directed and a non-directed graph? The directed graph is A is not symmetric and undirected graph A is symmetric. And if A is symmetric, then we can't say whether the normalized version will be symmetric or not. We can't say that. Okay. So that's what. If A the undirected graph A is symmetric and P may or not be symmetric. Okay. So if A not symmetric, P obviously cannot be symmetric. So it can have complex eigenvalues and may not be diagonalizable. This is one of the things. So if we see one of the formula, one of the theorem, okay, one of the theorem says that if Perron-Frobenius theorem is there, where A is a square and irreducible adjacency matrix, P is a normalized adjacency matrix, the largest magnitude of P is 1. Okay, so uh, means we have to why we consider the largest magnitude as 1. Okay, because we need to calculate the largest adjacency matrix because it is already normalized. Okay, so normalized matrix means it will be normalized with respect to rho. So every normalized matrix will have can have largest eigenvalue as 1. I hope all of you agree. Okay, so right eigenvalue, and now we need to calculate the right eigenvector. So what is that right eigenvector? Like Ax is equals to lambda x, as we see Ax is equals to lambda x. So as we know, this x is binomial is right eigenvector. I hope you all agree. But what if we write x transpose A is equals to x transpose lambda x transpose? Then this x will be left eigenvector. Okay. So this is what. So in order to calculate stationary distribution, that is different from a normal distribution, a normal eigenvector, this is called stationary distribution of page rank vector. I hope you agree. Okay, which satisfies pi transpose P is equals to pi transpose, where pi is an eigenvector that is satisfying the lambda is equals to 1, because that is a maximum eigenvalue. Okay, so if we write A as some adjacency matrix and Pij as a normalized normalized adjacency matrix, then P transpose pi transpose P is equals to pi transpose. That is if we get the steady state probability, and if we approximate with respect to only one value, one p-value, so we can approximate with respect to hyperparameters. Okay, so as we know, we have to compute eigenvalue and the eigenvector, and you can get these values. Okay, so if we see the inverse eigenvalue, then if we have the eigenvalue lambda and we have to compute a, how will you compute? Suppose you have eigenvalues as pair as given. Okay, now you want to compute lambda and a. How would you compute? How would you compute? So if lambda and x is given, so you want to compute a, where a11, a12, a21, a22. So that ax is equals to lambda x. So two equations and four unknowns. That will be different. Okay. But if more number of unknowns is there, then what else? More number of unknowns is there. What else? They will be creating a wide matrix where infinitely many solutions exist. If infinitely many solutions exist, then what can you do? You remember least norm. The least norm solution can be A transpose. Okay. So anyway, this was the least norm solution. If you remember the least square solution, A transpose A whole first, A transpose into Y. Okay. So since this is just a quick revision class, so I'm not going into it. But yeah, I have dealt this in my main class. So how to solve this type of problem? Okay. Going to the Knocker product, Kronecker product. Uh, this is the formula. How to will you get? So if you are, it is actually not a simple matrix multiplication. It is different properties, but using Kronecker product, you can actually get uh, if you have lambda values, and you can actually get the matrix. Okay. So this is A11B, A12B, AMNB, M1B, M2B, and this MNB. Okay. So if properties are there, so AC knocker product with PD. Okay. So that is there. Okay. You can have the multiplication and then the sum, and you can do that. So also one of the main property of knocker product is vector of IBC is equals to C transpose knocker of I, vector of B. Okay. So you have set of values. So using knocker product, you can actually predict. So that is one of the things. So Ax equals to lambda x, and this was the formula. Okay, you have the diagonal matrix eigenvalues. You have to compute A such that Ax equals to lambda x. For example, A is symmetric, so A transpose equals to A. Now, again, if you have with eigenvalue and eigenvector, you can easily demonstrate. So the thing is, you will have so many Markov chains. So with so many Markov chains, which one will be the best one? So how will you decide? So in order to do that, we'll have you need to get a Markov chain which is fastest mixing. What does this mean? So fastest mixing in the sense of undirected graphs. Okay. So if you have a graph that is defined for V and E, so if Pij not equal to 0, and if Ij exists between the edge, and if Bij is equal to 0, if it is not belong to edge, the adjacency matrix is symmetric matrix, normalize the adjacency matrix, provide, provide transition matrix using the page rank, and whichever value it is giving as a fastest mixing, that will be the fastest mixing marker. So mod of lambda 2, lambda 3, lambda n, which is very close to 1. So what we have observed is if P is symmetric and if you have these values, so construct a Markov chain on the graph whenever there is an edge between the vertices. The transition from I to J can happen. Assume that P is symmetric. So this is the way. If there exist infinitely many solutions to this means that there can be many. But which one to select? Suppose you have infinitely many solutions to this problem. As we know, there will be so many solutions. This means that there are infinitely many Markov chains that converge the same stationary distribution. If you have the stationary distribution, and that is a page rank vector, and you have eigenvalues, so which Markov chain to choose? Okay, so which one to select? It is a fastest maximum Markov chain. If you recall the power iteration, so it shows this lambda 2 by lambda 1 and lambda n by lambda 1. Okay, so how fast this Markov chain converges to its stationary distribution is determined by mod of lambda 2 p. So magnitude of second largest eigenvalue. So this will frame the optimization problem. Lambda 2 p pi transpose p is equals to p. You understand this? If you don't, if you have problem, just let me know. We'll wait for 2 minutes. Okay, so yeah, since 1 is the dominant eigenvalue p, 1n is the corresponding eigenvector. Pi transpose p is equals to pi transpose such that this eigenvalue eigenvector pair satisfies p transpose p is equals to a symmetric matrix. Pi symmetric because it's an undirected graph and it is 0 for this not belong. So this is a undirected property. Okay. Okay, I think week 11 was this one only. Uh, I don't know why there was problem in week 11, but still, since they asked me. But yeah, if you say me, I will also upload these solutions to your PDF files, so I will not have any issue. But if you want to calculate the diameter of the undirected graph represented with the following adjacency matrix, what is the answer? So we need to make a graph like this, okay, and we have to calculate the shortest distance. The shortest distance between uh, 1 and 5. 1 and 5 is, okay, nodes are this one. So 1 and 5, shortest distance between them. Okay, 1, 2, 3. Okay, so we need to calculate the shortest distance. Okay, so as an undirected graph represented by Q in question one is strongly connected. Tell, is it strongly connected? Think about it. So, first of all, unrelated graphs can only be connected. They cannot be strongly connected. They do not possess any notion of being strongly connected since the edges are bidirectional. Okay, moving to the next question. Now tell what will be the order of adjacency matrix for a graph having P nodes and Q edges. So there are four options. Tell what are the answers? What is the answer? So you remember how will you calculate the adjacency matrix? If we have 6 nodes, then 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, then associated weights. So definitely the answer is P cross P or Q cross Q. No, but yeah, nodes is important. Q is doesn't matter. Edges won't matter. So P cross P. If the answer is also P cross P. Now tell me the knocker product of these two matrices. Write in the chat box. How to calculate knocker product? If you remember, if you have AII, A11, A12, A23, A21, A22, and this is B11, B12, B21, B22. Let us assume that B matrix is B. So what was that the formula? A11 into B, A12 into B. So it is a block matrix kind of thing. Okay, all remember? Yes, fine. So this is the way how can we do. I'm repeating the again like whatever we have done previously. Now tell what is the formula for this. The singular value of the matrix A are sigma 1, sigma 2, sigma 3. What will be the singular values of A power 5? See, the hint is there, my own notes. Definitely it will be how singular value works. Singular value works if any rectangular matrix is there, then A matrix can be written as U sigma V transpose, where U is eigenvectors of A transpose and V is eigenvectors of A transpose A. Make sure this U and V are normalized matrix. So these are the normalized matrix. So as A can be U and sigma. So as we know, this A power 5 if you want to write. So U sigma power 5 B transpose. Okay. So sigma is nothing but sigma 1, sigma 2, so yeah, sigma n. So since it's a diagonal matrix, so sigma power 5 will also lead to sigma 1 power 5, sigma 2 power 5, or sigma n power 5. So definitely the answer will be A. So consider the following graph with A denotes 4 graphs, 4 probability transition matrices. What are the entries of A transpose? How would you calculate? See, based on your request only, I took the week 11. Otherwise, week 11 was easy. Okay. So I hope you all know we need to create 1, 2, 3, 4, 5. Make sure it is A is not an adjacency matrix, it is a probability transition matrix. So you need to normalize with respect to row. I'm again repeating here, you need to normalize with respect to row, not column. So, and A transpose, see, what they asked in at the end, say A transpose. Okay. So now if it is an initial importance vector, this is very important. Can you tell me what is the formula for V1? If the importance vector it is given, so what will be the importance after some clicks? Okay, so I'm telling you one of the formula which is very important. Using this formula you can tell. So pi 0 transpose p is equals to pi 1. So what does this mean? The initial importance vector is equals to transpose into p, which is a probability transition matrix is equals to pi 1. Okay, so using this feature importance, you need to calculate. Maybe what if after pi 1, pi 2, pi 3? So you need to multiply multiple number of times. So after multiplication of the multiple number of times, you'll be having. Suppose it is pi 2. So how will you calculate pi 2 using pi 0? Pi 2 using pi 0. So pi 2 is nothing but pi 0 square transpose p. How it is? It is pi 1 transpose p. And what is pi 1 transpose p? This pi 1 transpose is pi 0 transpose p whole transpose p. So pi 0 transpose p square. Okay, so my thing is wrong. Pi 0 transpose p square. Okay, so using this you have to calculate. Okay, see, either pi, so but yeah, you remember, this is transpose. If it is pi 0, so then p is transpose. Or another way you can write, because it's symmetric matrix of p p square transpose into pi 0. So after infinitely many tests, which web page will be ranked the highest? How will you calculate? This is answer is 2, but tell me the logic. How will you calculate? So if you do the stationary distribution, how will you do? That is pi p is equals to p with eigenvalue of 1. So that pi that you calculate is actually the stationary distribution. Mhm. So you need to calculate the stationary distribution and then you have to find. Or else you can do this where limit n tends to infinity a n power t transpose, which is a transpose into v0, where instead of solving this equation, one can look at the index of the maximum value in v1 and v2. Okay, because why I'm telling my maximum value in v1 because the importance with every iteration, the maximum value in v1 v2 will be only the one. So we will find the importance of second index keeps increasing. So the index will be keeps increasing. So after infinite many times, the second web page will be most important. The maximum eigenvalue, the paying graph average is always 1. So we completed week 12, week 11 again with a sure shot and within half an hour only we completed. Okay, so I'm again repeating week 12. So our main thing is, I'm just trying to uh, repeat it. So applied linear algebra in AI and ML. So actually, this course completely completed. And if you are not able to watch sir's video, then even if you are able to watch mine, I think that will be clear. So this course content was divided into introduction to vectors, scalars, linear independence, etc. Especially subspaces, etc. Then this is the most important thing, solution to Ax is equals to b. In this solution, we were struggled enough to find A inverse. So in order to calculate A inverse, we had LU decomposition, QR decompositions. Okay, because this both gives A inverse as easy or not difficult. Okay, this solution to now this solution also have two parts, three parts in fact. The matrix A is square, A is tall, A is wide. So if the term comes consistent and non-consistent, so consistence means consistent, non-consistent. no solution exists. Solution exists. Now you have these things. Okay. So if A is square, then definitely Ax is equals to B. This is implying x is equals to A inverse B. But if A is tall, tall is this way. You have number of equations less than number of unknowns. So here in this, the first one, system is always consistent. Here, second one, system may not be consistent. Okay, system may or may not be consistent. Okay. Okay, shall we move ahead? So, what does this mean, consistent and non-consistent? What if you're not able to calculate because here you can see number of equations is less than number of unknowns. So, you're not able to approximate with respect to unknowns. Okay, if you're not able to approximate, then in that case, definitely there will be no solution. Okay, so, but approximate solution exists is x is equals to A transpose A whole inverse A transpose into I. This is also called least squares solution. Here normal A inverse calculation is required. Okay. So A inverse calculation will be like LU QR or something. If you want to, if the dimension is less, then definitely you can calculate A inverse. A inverse normal formula of A inverse is adjoint of A divided by norm of A. But if you calculate the adjoint of A, then if the n is very high, A inverse calculation is very tough. So for that only LU and QR become is needed. So if least square is asked, so what you have to do? You need to calculate using this, but still this matrix will be there. This is also called gram matrix. This gram matrix is always orthogonal. Do you know what is the property of orthogonal matrix? If we multiply any vector with any orthogonal matrix, then suppose this comes Q dash. So norm of Q dash is equals to norm of XQ, or you can write QX. First property. Second property is Q transpose Q is equals to Q, Q transpose equals to I. Third property is Q transpose equals to Q inverse. Also, rotation doesn't change. So this was the second part. Okay. The third one is when the A is wide.
Hmm? In this case, you have wide. If this wide means number of equations is greater than number of unknowns. Now you only think if you have more equations and less number of unknowns, then you can approximate. Okay, approximate in the sense if you have suppose x plus y is equals to 5, x plus y is equals to 2, 3, y is equals to 6, x plus 2x plus 5y is equals to 7. If you are asked to calculate, oh, so sorry, opposite is there. Nobody pointed. Now tell me what is the solution of this pair of equations. Do you think that they here inconsistent problem exists? No, because here you are having, suppose you want to calculate these two values. So if you have no more number of unknowns, so equation can be satisfied. Suppose you want to make z as a variable, and if you want to solve x and y, so z variable can be any value from minus infinity to infinity in the real axis. But it should it can it for x and y the values will be satisfying. Do you agree? So here the problem of inconsistent never exists, and thus we also have infinitely many solutions. No inconsistent. Okay. So what is the formula for this calculation is x is equals to A transpose A transpose whole inverse into y. This is also called least norm solution. Okay. And also remember A transpose is also orthogonal. So if you remember this thing, this is very, very important. So yeah, first thing is covered. You remember the most important thing for your exam is subspaces, linear independence, vectors, and also norms. Hmm? If I go deeply into norms, not deeply, but yeah, thoroughly, L1 norm, L2 norm, so on, L infinity norm. Also, L0 norm also exists. X, but it doesn't follow norm properties. So it is, but this norm is there. So L0 is number of non-zero entries. L1 is, so if I write in journal the formula for LP, so LP is x1 power p plus x2 power p, so on xn power p, whole power 1 by p. So if I write L1 in using this, mod also. Okay. So if I write L1 using this, x1 plus x2, so on, xn mod 1 by p. Similarly, L infinity is max of x1, x2, so on, xn. Okay, so in 2 dimension, if I plot using different colors, I will plot. So ignore my so this is infinity, this is 2 norm, this is 1 norm. Okay. So you need to remember that L1 norm or L0, if you minimize it all, it ensures sparsity. Sparsity means more number of zeros and less number of positive vectors. Okay. How would you ensure that? So not red, take green. If you pass a line through L1, okay. So if it is crossing through x1, if it is this x1, this is x2, it is not crossing through x2. x2 is 0 for sure whenever you are passing through x1 as a solution. But if you are passing the line for L2, touching the L2, so this is both is having the values x1 and x2. So L1 norm helps in regularization for some of the use case. So it ensures sparsity. I hope norm is also clear. Then the most important thing is third part, which is a SVD and EVD. What is that? SVD is singular value decomposition. It's a basis for everything. And EVD is eigenvalue decomposition. So if we go deep into it, singular value decomposition is for all matrices. Means need not to be square matrix. For all, not for all matrices. Need to be square, which is also called spectral value decomposition. So if we write EVD for any square matrix A, so A is equals to V lambda V inverse. So this lambda is the lambda 1, lambda 2, so on, lambda n. V is eigenvectors of A. So from this you can say that AX is equals to lambda x also only valid for square matrix. Okay. Okay. And when V inverse equals to V transpose, when V is orthogonal. When A transpose equals to A, or symmetric matrix. Symmetric matrix. Whereas SVD is for all matrices. SVD states that any rectangular or any square matrix can also be written as. So what you have concluded from this? SVD is equals to EVD for square matrix. Okay. So this is U sigma V transpose. Okay. Where sigma is sigma 1, sigma 2, so on, sigma n, 0, 0. Where sigma 1 is equals to root over lambda 1. Sigma n is equals to root over lambda n. Also, sigma 1 greater than sigma 2 greater than sigma n. Okay. So, yeah. So, yes. This is this. And U is equals to eigenvectors of Gram matrix. A transpose. V is equals to eigenvectors of A transpose A. Okay. I hope this is clear. And so, if any doubt, staying here for 2-3 minutes because 1 hour is about to complete. And week 11, 12, 12 is basically end of everything. SLRA, structured low rank approximation. Then week 11 was page rank. Just now only I explained. So that will not be issued. Okay. Still I'm waiting for 2-3 minutes. Just let me know. Okay. So okay. So I'm still waiting for 2-3 minutes. Anyway, I have concluded everything. Still, if you have doubt before exam, I think exam date is 27 or 28. Let me know through email ID or through anything, whatever you like. I'm here to help you. Whatever required from my best, I'll help you. And try to fill the uh, feedback form if possible. and this was the week 12. Using this particular formula, you need to calculate the, because this singular value decomposition can also be written in terms of rank 1 matrices. Okay, so that will also be helpful. So you can see this problem, especially the solution part, because it's in sigma 1 greater than sigma 2 greater than sigma n till sigma n. So we can remove some of the vectors. Week 12 is easy. Week 11 is easy. You can cover up to week 10. And the norm thing is also important that I told. Rest is all. So all the very best for your exam. Thank you so much for listening to my classes and whatever comments. Like, I'm open to feedback. If you don't like my teaching, do let me know. If you like also, please do some comments. And okay, thank you so much for watching. I would like to take your leave.